this is section F here. This is called quadratic models. And what we're basically going to be doing in this section is solving word problems that are situations that can be modeled with quadratic equations or quadratic functions. Okay, and they're going to come down to about 3 different things that we have to do in order to solve these problems. Some of these problems we're going to just have to substitute and evaluate. Sort of strategy number 1. Strategy number 2 is the answer that we're looking for in this question is represented by the x-intercept or x-intercepts of the parabola. So we're going to have to find those x-intercepts either by factoring or by using the quadratic formula. In other cases, the answer to our question is going to be represented by the vertex of the parabola. So we're going to have to find the vertex by completing the square, or we could find the x-intercepts and then use the x-intercepts to find the vertex. Okay, so let's take a look at, I think we're going to do 3 examples here. Let's take a look at our first one here. So a soccer ball is kicked with a vertical velocity of 20 meters per second. Its height, h meters, t seconds after it is kicked, is given by the equation h equals -5 t minus 2 squared plus 21. And we're asked a series of questions about this situation. First question, what is the height of the ball after 3 seconds? So when we approach a question like this, the first thing we want to think about is what are they asking us to find, and what information are they giving us? So they're asking us to find the height. Okay, height is going to be a value of h. They are giving us this value of 3 seconds. This is going to be a value of time. P equals 3 seconds. So in this equation, h equals -5 t minus 2 squared plus 21, they are telling us what t is, and they want us to find h. So to answer this, all we have to do is sub that value of t in to the equation for t and evaluate for h. So h is going to be -5 our t minus 2 squared plus 21, and we're going to sub in our value for t, which is going to be 3 seconds. And now we just have to evaluate this. And we're going to evaluate this using order of operations. We're going to start inside the brackets there. 3 minus 2 is going to be 1. So we'll have 1 squared, and we're going to keep everything else exactly the same. And then we can do our exponent. 1 squared is just going to be 1. So that's going to be -5 plus 21. -5 plus 21 is 16. So the height of the ball, h equals 16 meters after 3 seconds. All right, our second part here. What is the height of the ball when it was kicked? Give ourselves a bit more room here. So again, what are they asking us to find? They're asking us to find the height. So we want to find a value for h. What does h equals? They don't give us any more numbers in this question. They just sort of say when it was kicked. So this word when in here suggests that what they're telling us is a value for time. And when the ball was kicked, we can say that that is t equals 0. That's like the starting point for the entire motion of the soccer ball. So again, just like the last one, they're giving us a value for t, and they want us to find the value for h. So we're just going to substitute and evaluate. Our formula is the same thing as it was before, but instead of subbing in that value of 3, we're going to sub in a value of 0. And we're just going to evaluate using order of operations. We're going to keep everything the same. 0 minus 2 is -2 squared plus 21. I'm going to do my squaring, so -2 squared, -2 times -2 is going to be +4. -5 times 4 is going to be -20, plus 21 is going to give us 1 meter. So when the ball was kicked, it had a height of 1 meter. When we're answering these kinds of questions, we should always double check at the end that our answer is reasonable. Does it make sense that the ball was kicked from a height of 1 meter? Sure, that's about the height that you would hold it up off, a person would hold it off the ground if they were going to drop kick it. Does it make sense that after 3 seconds the height of the ball was 16 meters? Sure, a ball could easily go 16 meters in the air. If we'd gotten something like 200 meters, we would know that we had done something wrong in the calculation. Or if we had gotten something like negative 16 meters, that would be impossible because the ball would be underground. All right, our last part in this question here, what is the maximum height of the ball and when does it reach the maximum height? So when we see, they're basically asking us to find the maximum height. Anytime we see this maximum or minimum in here, we know that they want us to find the vertex of the parabola. Okay, and both parts of this question have this word maximum inside there. So both of these are going to reference the vertex. So let's find the vertex of our parabola. Let's just write down the equation here, negative 5t minus 2 squared plus 21. Well, this parabola is already in vertex form. So we can get the vertex right away. Our vertex is going to be 2, 21. And we're getting that, of course, from the value of h and the value of k. H and k. Now, in this vertex, 221, one of these things represents the maximum height, and one of them represents the time when it reaches the maximum height. So our vertex, 221, is a coordinate, right? Ordinarily, with coordinates, we have an x and a y. With this parabola here, our variables aren't x and y, they are h and t. So t is taking the place of our x, and h is taking the place of our y. So 2 represents a value for t, and 21 represents a value for h. So when they're asking for the maximum height, we can say the max height is 21 meters. Okay, that's our h value there. It reaches it at a time of, we want our t value from the vertex, 2 seconds.